So a recapture of yesterday's. So we have discussed about Moore's law, postulated by Gordon Moore based on his empirical observation. Empirical means whatever is happening, what he is seeing, and trying to observe, trying to gain some understanding, trying to gain some wisdom about what is happening, how the progress is happening in terms of electronics and the related technology. So he made some empirical observation that there will be doubling of the amount of transistors that could be embedded into any unit area. Unit area means a square centimeter or a, you know a piece of particular area, a two-dimensional area on which how many number of transistors could be embedded. So that keeps on increasing. In fact, it keeps on doubling day on day. That's what he said, and that was taken as a kind of challenge, and the electronics have been developing since then, and we have a rapid pace of advancement happening. So now we are in certain stage where both the storage as well as computing has become really cheaper. Yeah, but still it is costly because you see the very rapid pace of advancement of technology, be it hardware or software. It's rendering the devices older very soon. So they have to be replaced or refurbished, and the cost of it is increasing day by day, which means that as we keep progressing in terms of technological adoption and engaging with the smart solutions, it's getting costlier day by day. So, and also one big problem is that we don't have, say, if I put 100 rupees and buy a set of hardware, and I am only using 30% 30% of in an entire day, only 30% of the time I am able to completely put this hardware into use. The remaining 60% it is idle. This kind of observations have been made by people, and they really don't know how to make the best use of that remaining 60%. That's one area where you are really leaking your investment, and at times the hardware that they are having is not sufficient. If the number of users of your digital services, or you see a sudden spike in the number of users who are using your digital services is rising, and you observe that your server is unable to serve all of these requests, which means that your hardware is not sufficient enough at times, and at times it is completely idle. So these are typical situations. So companies are really confused. So what to do? How could I scale up or scale out my hardware on demand? And how could I make the best use of my hardware without you know running it on idle basis, not doing any much work? Literally one or two users are only using it, so all your processing power and RAM is not really working. So they stumbled upon this idea where cloud computing, wherein you need not have to put some upfront investment. uh, Cloud service providers who are really experts in managing data centers are doing that, and they are giving you a provision wherein you can start building the infrastructure, digital infrastructure, on a virtual basis. So they'll give you a login, there is a portal, and you can drag and drop, or start creating instances of hardware in a virtual mode. You can just feel it. So, and you can start putting your systems, applications, the entire digital infrastructure there, and you can start giving those services to your customers, and you see the wonders happening there. Almost something that is which is equivalent to a data center which you run, something better than that. The peak times that are required by this company, where they are not able to scale up the hardware The cloud, since it is a pooled kind of resource, at that particular time, when some other resources resources which were reserved for some other customers would have been idle, those resources have been virtually clubbed with the resources which are in demand, which means that if a company has to scale up on a dynamic basis, so if you give provision a choice for you when you are provisioning a server to increase based on demand, then automatically you will have additional hardware getting clubbed with your server resources so that you are able to give the peak load service without any interruption, which was not which was not really possible when you have a limited kind of data center. And during your non-peak times, you will be allocated very minimal resources to serve that non-peak load, and whatever is the additional resources that are being idle for you will be given to someone else who is having demand at that particular point of time. So you can literally increase and decrease your hardware capacity, which we call it as elasticity, elasticity of resources, literally computing resources. So this is what I attempted to teach you yesterday, and this is a benefit. So is cloud literally a solution for all your problems? No, maybe it's a fancy word, cloud, but it is a solution for majority of the problems faced by IT or digital solution or digital service providers. If someone is literally running some softwares through which they are running their business, for these people, majority, 80% of them think that yes, cloud has given a real solution to us. We are only paying them only for the usage that we are doing, and we are not really coughing up huge upfront investment, capital expenditure. So in that way, we are saved. So whatever we are using, we are only paying for that. If tomorrow our business suddenly closes, we don't have any hardware remaining, so that we have to go and sell it again. We will just stop the business there, which is not running. And if any new idea comes, we can immediately provision the hardware and the infrastructure required for it. So this kind of, you know, instance provisioning and instant shutting down of digital infrastructure has come handy for almost 80% of the companies. And remaining 20% typically who think that data is really a very big secret. We cannot part with the data. It has to be with us. And there will be some scenarios wherein data has to be very near to the people who are working. Only then you can feel really technology is efficient. If it is in cloud and you don't have proper connectivity, and data has to reside very near to the workers, those are the instances where the trade-offs or the decisions that the management people make, that they don't want to have cloud. They think that on premise is much better as compared to cloud. Definitely they'll go ahead with the cloud, nothing wrong with that. But as I said, 80% the world has seen the benefits of cloud, and they are adopting it and advancing based on the provisions made there. Really, you need to have very good bandwidth internet for the cloud to be successful. You may have to have redundant internet network lines. Redundancy here means if I have, say, ACT fiber connection, and if sometimes ACT may fail, then as a backup I will have Hathway. If that is also failing, then I will have some other things based on satellite. or we'll have some other alternative connections like 5 or 6 times redundant. So if something fails, we will have second thing ready already there standby. And even if that fails, we'll have some other thing on standby. So we really see that network is interrupted very rarely, not even rarely. It never happens. It's always available. So use it at particular point, and the cloud infrastructure is sitting elsewhere. You are connected with it with this redundant arrangement. So if one thing is failing, you have another thing readily available, so that your interaction with the cloud or computing infrastructure is never interrupted. That's one thing really which is required for the cloud to be successful. At least it may be for the person, you as an administrator of the digital infrastructure, or your stakeholders who are interacting with your digital system. So both of them require a network, a very good network. Otherwise, it may be failure. So that's the limitation of it. So only limitation is the availability of internet, and internet keeps on getting more and more stronger day by day. So yeah, that's something which has to be seen. If it really if it really internet connectivity is going to render the cloud successful or a failure, that is to be seen. But as of now, it's not really creating much problems. It's giving service on real time basis to the satisfaction of all the customers. Yeah. And now today's topic: data and information differences. What is data and what is information? Data is something like proper arrangement or sorting of the raw facts that you collect. Say at 11, this assume that this is a telematics data. Assume that I am I am a railways manager, and I want to monitor a train. Okay, at 11 a.m. for every 1 or 2 minutes, I want to record the speed at which the train is running, 120 kmph. 11:02 a.m. So this kind of data that you will be collecting. So you'll be collecting the time and the speed of the train at which it is running based on a sensor and automated, data collection arrangement, an embedded arrangement within your train. So this is data. If I don't tell you the context or the relationship between these two pieces of data, you can't make any information out of it. If I say at 11 o'clock, this is the speed at which the train is running, I am putting you into one context and making you understand this relates to the speed at that particular point of time. And now if I ask you, is the train accelerating or is the train braking, or is the brakes applied or is the accelerator applied on the train, you can see within 2 minutes it's able to increase its speed by 15 minutes. So the train is increasing its speed, it is accelerating. That's the kind of information that you can make out of the data that is available here. So you put the data into a particular context, then you'll get the information. The context here relates to business. You put any data into an appropriate business context, only then you can make information out of it. Otherwise, the data is, you call it as raw data, it is sitting somewhere there in the database. And if you don't put any business context, really it would be very difficult for you to understand. You may keep on thinking for days and days together, because this is simple piece of data. You are having only two values here. time as well as speed. And in the real day business context, you are collecting a lot of information related to each and every activity that any particular business into. Any data that is of interest or that which is not of interest, but still it may found to be interest data of interest to the company in at a future point of time. They'll be collecting. They may not be using, but still they'll hold it. All this data, if you have to make a sense, you have to put proper context to it. Otherwise, you will render the data as meaningless. So that is the data. That is the difference between data and information. So how is this related to our understanding? Yeah, we as data engineers may enter into a company, a service provider company, maybe TCS or Accenture or HCL or Infosys or any other company. These companies really serve to the clients who are running their own businesses, maybe an insurance company, it may be a medical services provider company. They may be having a business problem and they want to build a solution for that particular business problem. Any problem solution will come in two parts. You can go and ask any architect over there in any organization. Architecture tries to simplify the complexity, and any architecture will have application architecture and data architecture. So application architecture is something which is dynamic. You can access a kind of URL over your internet, or you can install an app related to that company. That company says you this is this app. You please go and install it, and you can start making use of our services. Say a bank says no, come and install an application, and that keeps on generating information. And through your activity, you may be generating information. This information or this data has to be stored, and how it should be stored, what details should be stored, that will be covered in data architecture. What is the application and how the stakeholders of a particular business interact with that particular business or with that particular context of the business will be defined in the application architecture. First, what has to be done? Next, what has to be done? If there is any problem, what should be done? That is what all application architecture about. The data architecture says you are a new customer, and the company don't have any information about you. It says no, just sign up, means fill up some data related to you. I don't know anything about you, please fill up some data and introduce yourself to me. That's where I am putting my first step and collecting the data related to the prospective stakeholder or the prospective customer of that particular company. So this is where the data lifecycle begins in the context of that application or that particular digital service that we are giving. So am I clear now? I would like to take a pass, and anyone having any doubts, this is the time for you. All good? So I am assuming that you don't have any doubts as of now regarding whatever we discussed. And I'd like to go ahead. Yeah. Now, data modeling, database design. Yeah. Data modeling is you would have heard a lot of things about data modeling. Data is everything, but data has to be organized and structured. And This management of data has evolved over a period of time, and general commonsensical, you know, things that which we think that this will make a database system more meaningful have been, like, become as a features. Like you really don't know when you have basic model of mobile has come to you, and you keep on thinking as it kept on evolved. Some really good features have been coming in, like a touch screen, like a kind of video one wherein you can interact, a kind of IVR system, interactive voice response system, wherein you can give your decisions, and something based on which you can book tickets. You need not have to go and visit any travel agency office. You can do it by your own on your mobile. And in this way you kept on adding a lot of features to the handheld gadget that you have been using. The same way, if there has to be a software which should contain the data and keep managing the data as the data keeps on increasing, as we keep on moving in the civilization, in the time, as the time passes by, we desire to have a lot of features. And there will be a lot of players in the market in that particular technology service providing area, like a database management system. And all these people will be competing with a lot of features. As you know, Nokia would be having some features. Later on, Samsung would have given some kind of disruptive technological features which would have rendered Nokia completely irrelevant. It would have thrown Nokia out of market, and Samsung would have occupied the entire market. We would have definitely seen those times when technology has evolved, and it has created a kind of disruption where one particular company has been wiped out of the market, and Nokia is still struggling to come to make its presence felt to the people. But still, really, people are really not don't want to look at them because they felt cheated. So some other companies are able to give good features. Why is that not able to give? Nokia is not able to give. So that's a kind of thing. So we'll have a lot of features added to it, and a lot of versions kept on coming in the database. And the basic there was some basic database design methodologies that we someone has postulated. There are some saintly people. I will give a quote of those people, and you can really make the knowledge given by them as a golden standard. Ralph Kimball. Believe me, if you put Ralph Kimball methodologies, knowledge, to say discuss something about Ralph Kimball methodologies, you know that, or you follow this methodology in implementing a database design or data modeling, you put that in your resume, somewhere that strikes a resemblance with a job description, particular job description. Some job description says that you should be aware or knowledgeable about Ralph Kimball data modeling methodologies. This is some saintly advice which was already given, which was still in practice. Which was still in practice. It has given a lot of, it has saved a lot of time, because all these things that the people have already had experienced the difficulties and found some techniques to overcome those difficulties in the field of data practice have been given in this book. I'll be sharing that book with you also. It's a PDF book, almost 600 pages. You can think of that. If you think data practice as a particular religion, just like a Hinduism or Christianity or Islam. If you think data practice as one particular religion in terms of technology, you can consider this as your Bible. Ralph Kimball. I'll share that book. I'll show you how that looks like. Excuse me. So you can make a note of it. I'll try to share this book with the definitive guide. So all the keywords that you find here, definitely you may be finding 70% of or 80 to 90% of any job description given in detail elaboration in this particular text. And this is a first class text, first class, classic reference. You can compare this to any devotional guide, say for Hinduism, Bhagavad Gita, for Islamic, Quran, in the same way, So whatever the religion, you say sacred book. And if you are a data engineer, this should be your sacred book, because someone out there who says that I am 20 years experienced, still you can interview them and tell them they are useless people, because no one will really remember all of this. And if you really remember and implement all of them, then you can create a revolution in the data practice. There is almost solution for every problem that the people are facing. It's like, pieces of puzzle. If you if you bring all these puzzles together and make a very good picture, compelling picture, that's what the companies will appreciate, because that picture here in this context is a kind of data solution that you are providing to the kind of problem that your customer is coming up with. So you keep reading and thinking about this, then definitely you will become one bright data professional some point of time in your future. This is something which I want to see, because I want you to see only the original texts. There may be hundreds of texts out there in the market, or someone may be like forselling you. You see the SQL complete reference, you see that, you see this. No, the fundamental concepts that which you are using to build any kind of database, all of this is coming from the Ralph Kimball. Am I clear? I would take a pause here and try to get some questions from you. Okay, I'm assuming that you don't have any questions.
Pratap, one question. So, is there anything important topics that we can refer in the Kimball, or you
Yeah,
see like mostly?
I'll be coming to that point when I introduce you to the kinds of data. And this is a traditional data warehousing idea, uh, in the way that it relates only to the structured data. So first of all, you have to know what is structured data, what is semi-structured data, what is unstructured data. Only then you can really feel, yes. Traditionally, data warehouses and DBMSs have been dealing with only the structured data. And what do you mean by normalization? Why do you really require normalization? What is transactional OLTP, online transactional processing, OLAP, online analytical processing? How are they different? What are the pros and cons of having these two kinds of database designs? What purposes it serves? These are all the details to be discussed. But
Okay,
whatever the
okay,
book I have shown you, even now, if someone wants to recruit some prospective employees for the purpose of data engineering, irrespective of whether they are doing it for Azure or anything, they are putting all the keywords which are available in this book in the job description. I have seen few hundreds of job descriptions out there, and if you try to put most of these, just try to have some knowledge by reading this and trying to you know activate that knowledge in terms of your realization, or how you imbibe these topics. in terms of how this practically works, how this is giving some benefit in terms of practical implementation. That's when you can talk about that in interview to the satisfaction of the interviewer, and ensure that your interviews is ultimately landing in success. So this is something that which you have to keep in mind, because we are graduates. Some university would have certified us that we are graduates, which means that we have passed the ultimate thing in our life, wherein academics have certified us that you are capable of anything. It's only that our effort has to ensure that we we are capable of doing something great in this field. That's how you have to prove. In university, that you will have limited time. You have to study that, go and answer a question paper, and then you are done. Here, it's not like that. Every interview is a different question paper. You don't know the syllabus of it. The job description may be syllabus at times, but the temperament or the mood of the interviewer, it may be the question paper. Your answers may not always be right. It depends on the mood of the interviewer and how he sees it, how you speak, how you sound when you speak, how he feels. So a lot of things are in play. They'll be recording. You will be visible. They won't be visible. They want to see you because they don't trust you. You may be using proxy or some things like that. You know lot of tampering has happened already. So people are really recording and trying to see if it's a real interview which is happening over there and not proxy. So a lot of restrictions on us. So we have to be confident enough. Only then we'll be able to drive through the interview in a successful result. Okay. I think I have made myself. So we'll go into more details about the data modeling. Don't worry about it, because we have a lot of things to discuss there. But I am just referring you to the original texts here, because you may have some time. I don't know how many of you are working, how many of you are really putting most of your time into preparing for becoming a data engineer, or preparing for a new job, or preparing for an experienced person's job. And my effort should help you to to garner this knowledge to the best of your benefit. That's what my intention all about it as a trainer. So that's the reason I am referring you to the original texts out there. This is the saintly advice which was still being practiced by a lot of architects also. So I see the Ralph Kimball methodologies very rarely people will put. Very rarely. If you ask at least 10 to 12 practicing engineers, they will not say what is Ralph Kimball is. I'm sure. You can ask any person who has done MIS or data science from any higher degrees, who have done higher degrees from USA, like MS in USA. You say Ralph Kimball, they said I would have heard somewhere. I heard this word somewhere in my MS. I really don't remember. As a data engineer, if you say that you remember all of this, then definitely you are making some difference. You are making yourself more meaningful than a person who has done MS. Just he would have done thousands of he would reading of thousands of pages. He would have remembered a lot of things. But this 600 pages of knowledge is what all the interviewers will be looking for, especially in India, generally. Because if you see any kind of questions in interview regarding data engineering, if you are not able to find more explanation there, you may be finding one sentence or one paragraph answer, and you may be interested in knowing more about it. This is a text where you will find a lot of information, like in a structured way, in a presented way, in a proper format. You wanted to say something to the people who want to learn, and that is put in some proper structure. So this has become popular. Yeah, it's not a single thing that he wanted to tell, but it's a complex web of things which make up the database. So this is a methodology. This is the original text that you have. Yeah. The next, big data characteristic features. So when do we call something as big data? Data which is really big. It's really big. Then how can you characterize the you know how can we put the characteristic features of big data?
which is unstructured.
No, no, that will come. That will come. That part will come to it. Um, but even before that, the 5 V's we call: volume, volume, volume is really size. 5 V's: variety, velocity, veracity. There is one more thing: value. So everything is really important here. Volume means like it's a fixed size of data. Volume, like amount of GBs. That's the size of any data that you can quantify. Like any kind of data that you say, how will you quantify? By mentioning its volume. Variety, pictures, movies, uh, music files, audio visuals, or Excel files, or PPT files, or any other files out there. So how many types of files that you have, that is variety. Velocity, the rate at which your data is generated. The rate at which your data is generated, that is velocity. Veracity, whether the data that you are generating and collecting, is that really meaningful, or your sensors would have failed and they are collecting some wrong data. They are not really collecting the correct data. If you are weighing 5 kg of certain product, and your Amazon as a logistics provider, if you order something and they are sending you, their weighing machine has gone wrong. Instead of 5 kgs, it is recording 2 kgs. That is completely wrong. It's completely meaningless, and that is recorded there, and based on that you are doing some analysis. You say you have purchased a wireless keyboard. That entire package would have been assumed to be 5 kgs, and if it is recording that to be 2 kgs, then your system says something is missing inside that packet, because it's supposed to be 5 kgs and it is only 2 kgs now. Your system is working properly, whereas your weighing machine is not working properly. That is veracity. Somewhere it is wrong. How trustworthy is your data? That is veracity. If your data is wrong, your decisions will be wrong. Value. If you are really calculating the value of currency which you are transacting, then that is having huge value, which means that when it comes to currencies, if something goes wrong, that is not acceptable. It has to be accurate as much as possible. Assume that you're recording the quantity of gold that is much more valuable as compared to your currency. Agree? Say you are dealing with platinum in your business. The weight of platinum or the value of platinum is much more than gold, and the numbers that you are recording related to your platinum commodity is much more valuable as compared to gold or currency. It has to be treated in a much more secure way. or dependable way or error free way. So these are all the characteristics of big data that you have to imbibe and give due importance in your dealings as a data engineering or data engineering process or data engineering systems or designing or implementing the data engineering systems. When you are into the project, these are the values that any data engineer should have when dealing with the implementation of solutions for any business, because ultimately you go and work for a variety of customers who are doing their business in different domains, business domains. So all of these traits of data are something of a real interest to us. If we don't give due importance to all of the collection of all of this, you are put into a context wherein you are expected to give due importance to each and everything of this particular properties or features of the data. If you are not giving proper importance to any one of this, then you can see the fire coming to you. You will feel the heat. So this is as important as that. Yeah. So now we'll deal with the types of data. That is structured data, semi-structured data, and unstructured data. Yeah. So structured data. This is the data that traditional RDBMSs have been using. Like you can say IBM's mainframe or MS SQL or PL SQL, that is Oracle SQL. These are dialects of SQL. Even IBM will use SQL to some extent. So SQL is a language standard that you tend to interact with the database and try to get your data, do inserts, modifications and deletions of the data. You do any kind of data manipulation within a database, you use one or the other dialect of SQL. That's when you will be dealing with structured data. All these scenarios means that you are dealing with structured data. Semi-structured data, you would have heard about something if you are really experienced. Otherwise you can go and explore what is. Even if you don't explore, we'll be covering them in detail. I will be opening a sample of these documents, try to put it before you, try to make you understand so that you get a feel of how this data is looking. JSON, YAML, we have some other formats, Parquet, ORC, Parquet, and a few other you know formats. Unstructured data, these are human friendly. You'll make a lot of sense out of this data. Really, you love this kind of data. Images, visual, audio. Yeah, so this is a very high level category. Images or pictures, visuals, something you can see, it may be still or moving kind of photography or videos wherein you can see. Audio, sound, which you can perceive with your ears and try to enjoy or try to understand, try to gain something. So if someone says something in an audio, you'll be able to listen to it and involve yourself and try to gain some knowledge. So this is unstructured data. Why it is called as unstructured data? Because computers cannot really make any sense out of it. It's only the role of computers here in unstructured data is only that of a messenger. You see, there was a camera there, still camera, or a kind of CCTV camera, and that is recording, that's taking images, or it's taking a video or audio visual of you, and it is recording and it's again conveying back to you. It's not tampering any with any kind of thing there. It's just taking it and giving it to you again. It really don't understand what is there in that and what is not there in that. That is called unstructured data. Semi-structured data. Semi-structured data is something applications will communicate with each other. There may be some system you would have heard about microservices or APIs, application programming interface, or you may have some configurations in your applications. These configurations would have been like kept in an XML sheet, and application would be referring to that XML sheet and getting the values like encrypted passwords, value like IP of a system which your application component has to connect with, what are all the values it has to use, things like that. If you have to really activate a particular role or deactivate a particular role, you want to put that as settings, that settings will be put in an XML format. If anyone are .NET or Java developer, they would be knowing about this XML. Most recently, that XML, since it is more verbose, lot of things are there. Like for an XML, if you see the structure of XML, then you'll realize what are the disadvantages of XML and why JSON is more preferred over XML. JSON is having configurations, and JSON is a kind of format in which data will be communicated between systems. YAML, yet another markup language. These are something which humans can read, though these are semi-structured format. You can make some sense out of it. Here, the data will be stored in a key value format. The value, whatever the value over there is some meaning added to that value from the key which is against that value. It's a key value pairs, kind of dictionaries. So key will give some meaning to the value. It's a meaningful data, really. So blindly applications will take the value against the key and try to realize and try to put it in some context in the business process. Business process software systems are an abstraction of automated business processes. Then the key value and whatever is against a particular key, that will be taken as value and put into a particular business context in that process. And the automation will take care of the remaining processing, and you will see that yes, business process is replacing humans and doing it in a tireless way without any mistake, because you have developed and tested the systems and they will be working in that way. This is the format. If you want to know more about it, MuleSoft is a software which will be making use of enterprise service bus. This enterprise service bus will be orchestrating the JSON data in in real time mode, live mode or real time mode. MuleSoft may be one of your technological choice for your career, but still that will deal with the real time data. That is also kind of data engineering. Just to show you big picture, I am trying to quote this example. And structured data. This is where if I have to run a school, I have a student what are all the attributes of students will I collect? The name, date of birth, his height, how he appears, his identification marks, things like that. Because he's a minor and you are a caretaker being a school, you should know some legally compliant data has to be collected. And you put some particular format for the purpose of collecting data. You put give an application form to be filled by the child. So any physical disabilities, health wise disabilities, all this data has to be collected. That will be put in a proper structured format. And you know the details of the subjects that the kids will be teaching, kids will be taught, the kind of examinations that you will be conducting, how frequently, unit tests, quarterly tests, half yearly tests, and what are the minimum and maximum marks that people are expected to secure. That details in designing a subject in a particular course, the details regarding the teachers, the details regarding the classrooms, the details regarding the periods, all of this will be collected in a proper format and that will not change. This is where we call as entities and attributes. Entities means there is a student, he is an entity. You may be having 1,000 students, 1,000 entities. Each entity will be having at least 10 to 100 attributes. Attributes means something which is defining that particular entity attribute. And entities are related here. Say a teacher is uh, teaching in a particular class of 100 people. You have 100 entities as student, and you have one entity who is a teacher. Entities, these two entities are related. This teacher is teaching these 100 people. Entity relationship. You are mapping that. This is a conceptual design that you are putting. Entity ER diagram is how you represent your business. You put all your attributes. And once this is in place, you have the business context in place and you can design your database because you know what all the data you will be collecting, which is of interest to your business. I'll give you more details. I'll keep on giving more and more notes that I have personally prepared. That will help you to enlighten yourself in terms of knowledge in the data engineering. I think we have exceeded 1 hour today. So before that gets overloaded, we'll try and stop this today. And I'll open the forum for any further questions that I can clarify to you.
Pratap, what are the contents you're planning to cover in this course?
Yeah, Ravi. I am planning to cover 50 to 70 hours. At the outset, I will be dealing with Azure Data Engineering, that is Azure Data Factory, and some part of Azure Data Bricks. So Azure Data Bricks, Azure Data Factory, I will be following the Ralph Kimball methodology that I have just told you. So the traditional, whatever is the data engineering which was happening there, as much as that which is happening in SSIS, similar kind of methodology will deal with Azure Data Factory and Azure Databricks. I will follow CRISP DM methodology. CRISP DM methodology. This is a methodology which you can Google it and try to explore more details about it. This is about this is a methodology that which you use in data analytics with Python or data science or AI or ML. So even this is a keyword which you can use in your resume and try to do some justice in the interview that you really possess this knowledge. Crisp DM, as much as Ralph Kimball is adding some value to your resume. If you have this knowledge also, that will help you.
Pratap, it is sufficient to get a job by ADF and Databricks, or we need to.
Yes, but I'll tell you,
Mhm.
assuming that if you have 2 or 3 rounds, assuming that
Mhm.
2 are completely technical, 2 rounds will be mostly technical completely.
Mhm.
And I am expecting out of these 3 rounds, 1 round will be thoroughly in SQL.
Thoroughly.
thoroughly in SQL as well as data warehousing concepts. The data
Mhm.
warehousing concepts, as I told you already, Ralph
Mhm.
Kimball methodology is the one which will have a lot of traction and importance in the interviews, because when you say data engineering, people don't know anything. If he is an
Mhm.
experienced person, then he will try to uh, he'll try to play with the knowledge that he is having in the interview.
Mhm.
He expects the same kind of knowledge to be available to you, at least in some of some common sense that should be available for any data engineering to deal with the projects, to understand something
Okay.
in a technical way.
Okay.
That is a text, Ralph Kimball's methodology, because Ralph Kimball's postulates have is having a lot
And
of importance that you
synapse is
can.
required for synapse.
Yes, Synapse. If you know Data Factory, I think
Yeah.
Synapse is a all encompassing thing. You can readily use your knowledge of Data Factory and Data Bricks in
Mhm.
Synapse.
Okay.
Synapse is the ultimate data warehouse where you clean the data and the cleansed data will go and sit
Yeah.
for the
Right.
purpose of projecting it into the BI reports.
BI reports. Right.
Yeah,
It is only
you can
structured data.
imagine. Yeah, yeah, you can imagine. Yes,
Mhm.
structured data.
Mhm.
It's a structured data. Yes.
Synapse, you mean it's a data warehouse?
It's a data warehouse. It's a data warehouse as much as Snowflake is. Don't confuse with the
Okay.
Snowflake with the data model. We have a data model called, you have star schema, galaxy schema, Snowflake schema. These are kinds of schemas which will be, discussed in Ralph Kimball's methodologies. Snowflake is, there is a software called Snowflake. You should have been aware of it.
Yes, yes.
That's a data warehousing software.
Yes.
So Synapse is something similar to that.
Which one is better, synapse or Snowflake?
No, I can't say anything, but recently there is a study which said that Synapse and Databricks is giving 10 times more efficient and 10 times more cost effective as compared to Snowflake.
Okay, but Snowflake is open source, I think.
Agree. But I'll tell you one thing, see,
Mhm.
as a data engineering guy, see, we should be
Mhm.
interested only in the data, kinds of data problems that our customers are having, the kinds of data problems that we are trying to solve.
Correct.
These technologies and techniques may come and go, just like your mobile phones, different brands will come and go. But the
Mhm.
kind of business and the kind of problems that we focus on, that may not change.
Yeah,
Some
right.
technologies may give some added advantage, some technologies may not give. Some other consultants like Gartner will come and say, yes, definitely this is performing much more better than that. Every
Mhm.
year they do study and they keep giving reports. So that
Right.
is a dynamic part. Being data
Mhm.
engineers, our focus should be on data and the problems of our customers. Because
Mhm.
ultimately that's what, until unless you service the problems of your customers, the data problems of your customers, you will not get money, right?
Mhm.
So, I mean, we need to focus on the methodologies, right? First.
Methodologies, data structure, because this is the lifeblood ultimately. Otherwise, we will make a fool out of ourselves when we are serving a particular technical role, being data professionals, right? Am I right?
Yeah, yeah, right.
Yeah.
Yeah, we have to reflect on that responsibility that
Mhm.
we are
Yeah.
going to shoulder. Yeah, tools are like, technologies. If I ask you to travel from from
Mhm.
Bangalore to Delhi, you can say,
Mhm.
if I go in bike, this is the pros and cons. If I go in car, this is the pros and cons. If I go in
Mhm.
train, these are the pros and cons. If I go in
Mhm.
an aeroplane, these are the pros and cons.
Yeah, right. Mhm.
So because you are aware, if you have that kind of awareness, then you can serve as an architect or a consultant or any kind of higher roles. You can become
Mhm.
president and vice president, because you can see the big picture and tell the actual truth, ultimate truth.
Yeah, right.
Fine, we'll conclude this class today, and yeah. So we'll try to, I will try to give all this books, or probably you can search it yourself in Google and try to get that, and you can start preparing, because this is a lot of things which can't be covered in classes, but I'll try to do as much, because my focus is to cover on the cloud data engineering part. I may not be able to cover more details in Ralph Kimball, but that is very important for you to cover or satisfy your interviewer, at least in any one of the rounds, assuming that you have 3 rounds.
Okay, Pratap.
Yeah, fine. Okay, then thank you. We are concluding. Hope today was a fruitful and added some knowledge and guidance to your career. Thank you.
So you'll be recording these sessions, right?
This is there, probably, even I am not sure. I see this icon recording blinking here, and will it be shared to you? I am really not aware. I'll
No,
ask
that's
them
fine.
and let you know. Yeah, or
Yeah.
you can connect directly. You
Okay.
can inquire. You can inquire with that institute people. They'll tell you.
No problem. I mean, not immediately means after it
Yeah,
commences the
sure,
actual
sure,
class.
sure. Thank you.
Hi Pratap,
Yeah,
last one question.
yeah.
So in Databricks, will you teach PySpark?
PySpark, I'll be dealing only with the features which are important for the Crisp DM framework. Crisp DM is one which I have told you. This is the process which we'll be following to make meaningful information out of the data. So whatever is required only to that context, that we'll be dealing. See, Python data engineering itself is a very big thing. If I have to touch upon that, I may require 10 additional classes. I am really not sure if the course coverage or contents permit us. But by the time data factory completes, we can take a decision on it, whether you want me to introduce you to data engineering part with Python, or Python data engineering part. But I can refer you, just like how I have introduced Ralph Kimball to you. I can show you original first class references to have the knowledge in data engineering part using Python. These are the ultimate sources that you can think, if you want to. So you can, so your aspiration is your limit. You can become whatever you want in the field of data engineering with the kind of sources that I provide you.
So for PySpark developer, so
Hmm.
how much Python is required?
As much that is required to process your data. Data will be loaded into Python programming language in the form of data frame, and you will be tinkering with the data available in the data frame. So how you do what you do is something that you can compare, which is very similar to SQL. How you will modify data, how, say, if I have an employee, date of birth of an employee, and you want to calculate the age, so you just compare that date of birth with the current date and try to get the age from it, right? You're deriving some additional column from it at that particular point of time, right? Hello, hello, Ramakrishna.
Yes, Pratap.
So how you do that in SQL? You don't have the age column, but you derive the age column from the date of birth column using current date, right?
Okay.
So you write a SQL statement to do that, right? In the same way is how you use Python, PySpark to derive some
Yeah,
data.
yeah, advanced concepts in Python like oops and all we don't use in PySpark.
Oops concepts and all, if you want to use, you have to build systems using Python, something which is very comparable to Java.NET. Python is, previously people used to say Java is a very big ocean. Python is much bigger.
Mostly data related part we have to learn in
Yes,
Python.
that's what I was trying to tell you. That's what is
At
my
least
intention.
as a for a data engineer, how much it is, required at the basic level, you're covering
Yeah,
this
I
part, right?
can give you those sources, but right now really not required, because initially we will be focusing on having our understanding in data factory. Data factory is visually interactive. You can drag and drop.
Okay.
So in data factory, will you cover all data flows and activities,
Most of that. That's what.
mapping
Before
data
that,
flow?
I require 5 to 6 hours to introduce you to the Azure data framework, Azure, cloud as such, how it is structured and all that. I require 5 to 6 classes, and then some 20 to 30 classes of data factory. And after that, we will be going to Databricks. As a prerequisite, I may, based on your request, I may consider taking 5 to 6 classes wherein I will be exposing you to the PySpark.
In data factory, actually, I know the meaning of all activities and
Yeah, but this training's purpose is to ensure that
practical
agree.
experience we need as well.
Agree, Ramakrishna. But we have remaining participants who may want to know it. So we are assuming that you don't know anything and try to give you genuine information here in this training, right? So you may be knowing, but some other people may not be knowing. We try to cover it in a comprehensive manner. Okay, then. Thank you. I'm
Thanks,
ending this
Pratap.
call. Thank you.